All right, let's get you guys in here, and then we can proceed. Happy Friday to everyone.
Yay! You made it to Friday.
We made it. We made it.
I get
Another
to
week.
play Minecraft tomorrow.
That sounds fun.
It's the
Sounds fun.
weekend.
It is the weekend. All right. So yesterday we talked about PBR. We went over the PBR guide, and you guys took notes, listened. Today we're gonna finish it up. I've got a few more slides, and that's gonna wrap it up for the first part of it. And then next week we'll pick up on the second part of that. All right. So let's see. Let's finish this. I went over your threads, and I mean, it just looks like you guys are still working on it. So let's do a quick run through and all right. So Richard, still where you are. That's fine. Let's see. Finish the first and second video. Fine. All right. Let's see. Okay.
I'm I'm almost done with the presenting. I just can't get the lighting right, so I've just been working on the lighting.
Okay. Okay. Just keep working at it, man. Just keep working. You'll get it. All right. So, how are you guys feeling about the modeling process? Do you understand the basis of what the ideas that I'm trying to kind of give you guys are?
Yeah, it's just we have to sit there and sometimes really time consuming.
It is very time consuming if you don't know it. But like after a while, when you guys do start understanding it, you'll see that it's pretty much the same process for this small objects that you're creating versus something giant like a character or a level or something like that. These principles are just minute or small versions of what you'll have to do to create those larger environments. So that's what I'm trying to. That's what I'm trying to get you guys. All right. Unable to work till Sunday. Okay, that's fine. Let's see. Progress. No, I need more progress, Maya. All right. Still with this. Okay. Hopefully you guys have gotten to your low polys and you've started to unwrap so that by next week you can have those textured. All right. This is looking good. This is looking good. I like the lighting. All right. And the 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 idea of this lighting, the way that I'm showing you how to light this is that you're essentially using the lighting to carve out the model, right? Like we've got some of this nice orange lighting, but it helps us that we have this warmer blue because then you can get some of these shadows here that that give you some of that the differentiation in the shapes, and that's what helps our eye see the the differences in the form and things like that, is that change in lighting and shading and things like that. And so yeah, this is a good start for everybody because I think a lot of you guys have gotten at least to this point, right? And that's good. So yeah, looking good, guys. Yep, and yeah, you got to unwrap it, so this is cool. I would straighten these out, like these two pieces right here, straighten them out because if you can see right here, the reason that it's doing this on your actual box is because it's not straightening. Like this line should match this line, or you're gonna get some weird texture stuff whenever you try to texture it. Your textures are gonna go in that direction. You see what I'm saying? So you want to make them as straight as possible on your UV island. All right. So yeah, Surge. I don't know what's going on with your model here. It looks like you've got UVs that are not flat and they're like on the side or something. So I think what happens is you only flatten this out and then these are still like straight on like this. That's when you get this texture stretching. That's what happens when that happens right there. So yeah, and you didn't bake anything, so this is just yeah. All right. I'll just go take a look at that again. All right. Let's see who else. All right, that's it. All right, so let's finish up this. Let's finish up this talk on PBR. All right. So when it comes to linear space rendering, linear space rendering is a highly complex subject. For this guide, we will take a very simplistic approach in stating that linear space rendering provides the correct math for lighting calculations. So just an FYI, this part is going to be like a little heavy on the math and the calculation and stuff, but we're not going to do any of that. You'll just see the equations, and if you guys want to do a little more research, you guys are more than welcome to dive into the math aspect. I'm not even too sure on that because I'm not a mathematician, but this is just telling you guys how it relates to the work that we do, right? So it creates an environment that allows light interaction to be represented in a credible real-world manner. For a discussion on linear space rendering, we must introduce the concept of gamma correction. Right? When encoding images for display and storage purposes, gamma correction is the optimization process of reducing bandwidth and bit allocation. This process leverages the human eye's perception of brightness, which approximately follows the cube root of luminance. All right, so the human visual system, the HVS, is more sensitive to relative differences in darker tones than in brighter tones. So what that is saying is that our eyes are much more sensitive to darker images, like in darker tones, right? For the gradation from gray to black, we notice those more than the gradations between gray to white. Right? So because of this, not using gamma correction is wasteful, as too many bits will be allocated to tonal regions where the HVS cannot distinguish between tones. All right? So where it's very hard for us to see the change in value, right? It's going to put bit depths in there, because what you want to do is you want to allocate the right amount of bit depth for your image, right? You don't want to be wasteful, or you don't want to not use enough, because then you're going to get noise and grain and splotchiness and weird pixel stuff because you don't have enough. But you don't want to overkill it, because it'll put information into bits that you don't want, into pixels that you don't want. So in a typical digital image creation process, the image is encoded using the encoding gamma function, such as sRGB OETF or gamma 1 over 2.2 for presentation on a display device. The display device, the circuitry, then decodes the image using its own decoding gamma function, the EOTF. A computer monitor will frequently have a gamma setting of 2.2, and I still set my 3ds Max to 2.2 as the gamma correction, so that it does that automatically. And there's a spot in 3ds Max. I'll show you guys how to make sure that you're rendering out in linear space workflows. So a linear color space intrinsically has no gamma correction. This is equivalent to effective gamma of about 1.0, which yields correct linear computations. However, in order to present the rendered image correctly to the viewer, it needs to be encoded into gamma space. All right, so computations of color values and operations on colors are performed in linear space. The process decodes gamma encoded values into linear values for our color maps, and from colors chosen while viewing on a monitor via a color picker in a color managed workflow, like your color picker inside of Photoshop or 3ds Max, right there. This process typically involves tagging a texture map to be interpreted either as linear or as encoded with sRGB OETF or gamma 1 over 2.2. The computations are then carried out in linear space, and the final rendered result is gamma encoded with sRGB OETF or gamma 1 over 2.2. All right. So a simplistic way of considering which maps need to be decoded is that if the map exported from Substance Painter or Substance Designer represents color that you see, diffuse reflected colors such as the color tint of a metal or the green color of grass, then it should be flagged as gamma encoded for the shader to interpret the map correctly. The maps to be flagged as gamma encoded in a PBR workflow are base color, diffuse, specular, and emissive. If the map represents data such as how rough the surface is, the roughness, or if the material is metal, the metallic map, then it should be flagged as linear. The maps to be flagged as linear in a PBR workflow are the roughness, the ambient occlusion, normal map, the metallic, and the height map. And a lot of these have mostly black and white information other than the normal map, which is blues and purples and like slight hints of green a little bit. So yeah. And that's what your quiz is going to be on today. You're going to have that quiz on the normal maps, and yeah, that's going to be after this. But all right, so with Substance Designer and Substance Painter, however, the conversion between linear and gamma space on inputs to the shader is handled automatically. So is gamma correction on the computed results in the rendered viewport. As artists, we don't usually need to worry about the linear computation and conversions within Substance software, as the software will handle this by default. So when using Substance materials via the Substance integration plugin, outputs are flagged for linear gamma space automatically via the integration and the host application's color management. However, it's important to understand the process when Substance maps are used as exported bitmaps rather than Substance materials. You may need to manually flag the textures as gamma encoded or linear depending on the renderer you are using. Usually, PNGs, JPEGs, Targas, or TIFF files are gamma encoded, while sRGB, OETF, and EXR files are linear. The sRGB decoding function, EOTF, converting from gamma space to linear space, is used in Substance Painter and Substance Designer and is defined by the IEC with all those numbers standard as follows. So this is the equation for linear space rendering inside of Substance Designer. You guys don't have to know this or anything. I'm not going to quiz you or anything, but this is just for your edification. All right. So at the time of this writing, the linear to RGB and RGB to linear nodes in Substance Designer do not use this formula for optimization reasons. This may change in the future release, but for the sake of simplicity, for all the conversions in this guide, we have used the following simplified but approximate conversion function instead. All right, so that is it on linear space rendering. Next week we're gonna do part 2 of this, and this is gonna talk about how we approach this inside of Substance. And this is the most technical kind of aspect of it. The other side is more artistic and how you as an artist should be using Substance and what you should be thinking about and different things like that. All right, so next you guys have a quiz to take for me. And after your quiz, you guys are free to go. Don't forget to post your drawing for the week. Don't forget to finish out your crates, the low polys, the unwraps, and then the textures. And if you guys want to get those extra points, hey, get the ZBrush and do the ZBrush version of it. Go the extra mile to impress. And I think that would that greatly improve your skills. All right, so does anybody have any questions about what you guys need to do, or are you guys ready for this quiz? Anybody scared to take this quiz? You guys got it?
I'm crossing my fingers here.
Yeah, I think you guys will do good on that. So other than that, I'm gonna post it up there, and you guys should be good to go.
All right.
All right, guys.